find the zeros means I'm going to set this function equal to 0. So, whoa, that wrote twice. So the zeros, we're going to set that equal to 0, which if we solve that, subtract 2 divided by negative 4, that is negative 1/2. So we have an x-intercept as 0 at negative 1/2, which we're going to sketch this. So at negative 1/2, let's just call this point 1, or negative 1. There's our x-intercept. Now to find our y-intercept, we'll evaluate this at 0. So negative 4, 0 plus 2 will be a value of 2, so we have the point 0, 2. Just like over here, it's negative 1/2, 0. So we have the point 0, 2. Now I happen to know that's positive 1/2, that's the problem. Alright, that just seems sort of strange. That should be positive 1/2, which makes this point, okay, let's call that 1. It's 1/2. There we go. That's a little better. Okay, so we have a linear function here, so it is going to be in a line, and therefore that's our sketch. And our second function here, find the zeros. Alright, plus 1 equals 0. Alright, subtracting 1 from both sides, we get the square root of x plus 3 equals negative 1. Squaring both sides, x plus 3 is positive 1, which makes x equal to negative 2. Now I'm going to go plug that back in to make sure that this works. If I evaluate my function, negative 2 plus 3 plus 1, this ought to come out to be 0, because that's what we set it equal to. That would be the square root of 1, or 1 plus 1 equals 0, and that is not true. So there's actually not an x-intercept. Okay, and in fact, this is a square root function. I'm going to go ahead and sketch the graph over here. Actually, no, let's find the y-intercept first. This was our x-intercept, and there is none. Alright, so our y-intercept, we will plug in 0, so the square root of 0 plus 3 plus 1, which is 1 plus the square root of 3. So this function has a y-intercept of 1 plus the square root of 3, so that is roughly 2.73. 2.73. 1, 2, 3. There's our y-intercept, and it does not hit the x-axis, which means it's going to curve up this way. So we have a function that looks kind of like that.